Okay, so let's get rolling. Oh, first, a quick funny story to make everybody's day. So yesterday I had a meeting with the couple of people with the Milwaukee Harbor Patrol Police. I have a boat rental business, and we had a couple of weird tickets that we were trying to figure out what went on with it. Meeting went fine. In the end, they because I had already paid the couple of tickets, they said, well, we can't cancel them, but they were gonna so what they did is they issued me a credit with the Milwaukee Municipal Court for future, like I got a $214 gift card effectively for future infractions. So I should have asked if it was transferable, because I have a buddy who gets in a lot of bar fights, and maybe maybe this would help him. Yeah, I mean, it was almost worth the $214. It was with safety equipment. It was on the boat, but they didn't think it was as accessible as it should have been. But the ticket was for missing, so it was all a weird misunderstanding. But it was fine. But now that I have a gift card to the Milwaukee Municipal Court, what am I going to use that? Well, I hope I don't have to use that. So the follow-up good story is the time I'll have to use that, I guess. Okay, so right after class, last time, I fixed the little bug we had in here, and I gave you a little thing. Bug was in our add end. We didn't set the current tails next node to point to the new node. So when we added something to the end, before we reset anything, we didn't make the old tail point to the next guy, so he was getting lost. So even though he pointed back, we weren't pointing to him. So it was just one line. Then we also had an issue in remove end where we were not resetting tail when we were down to a 1 or a 0 list. So they're both fixed in the code now. We effectively have our original linked list, but this time of strings. Okay. And we certainly could have taken our original linked list and maybe made a new kind of node. I think I mentioned this last time, where we could have had more of a generic node and then created child classes of that. Maybe have a node that knows how to hold ints, another node that knows how to hold strings, things like that. All right, but we're doing this we built kind of a special tool specifically for Shunting Yard. All right, so our goal today is to build out a linked list that looks like this. This will be, I mentioned last time, this guy right here. We're building this input queue. Then we'll talk about how Shunting Yard works. So let's go ahead and do that. So I'm just gonna steal my sample input string. I might already have it in there, but just in case. And actually what I'll do, well, we'll write it out here, then I'll bring it into Shunting Yard. So we're going to create a string S is equal to this dude, and need to make sure I fix my double quotes there because it pasted in as funny ones. All right, so I have a guy like this. I want to go ahead and process through this to the point that I ultimately get a linked list that has these individual elements in it. In fact, I'm going to go ahead and write this inside of a Shunting Yard object, since that's what you're going to be adding to for your homework. So we'll just do it the right way first. So I'm going to create a Shunting Yard HPP. And we're going to have our class Shunting Yard. We'll have our private string expression. So we're going to need the string class, include string using namespace standard. We're also going to need to have our linked list in here, include linked list of strings. .hpp, linked list of, I call it string or strings? Strings, good. So then we'll have our linked list of strings. Call this guy LL. Actually, let's call this guy the input queue, because we're going to want to start naming these dudes something reasonable. So it's going to be a pointer to that guy, because again, we're angling towards building this. So we're going to have an input queue, we're going to have an operator stack, and we're going to have an output queue, but we're going to use our single linked list of strings to accomplish all three of those. We've built it in such a way that it has all those individual abilities it's going to need. It can behave as a stack, it can behave as a queue, and it can behave as a linked list where we can add and remove from the front, which is effectively a stack plus a queue. All right. I'm lost. Oh, there we go. All right, then we're going to have our public constructor. And this guy will be a linked list of strings. We'll go ahead and have him take in our expression as a parameter. All right, and we'll go ahead and give him a display function just for us to test what we're going to do today, make sure it's working. Because effectively what we're going to do inside of this constructor is we're going to take in that string that looks like an expression, and we're going to do all the magic to split it into this linked list of strings. So that constructor will do this to this. We're just hiding it inside of that new object, because that new object is going to be the guy that has a function maybe called do math. That'll be what you'll do over the weekend for actually using Shunting Yard to accomplish this. Okay, or at least in part. I'll have to see where we get to in this. I might just have you do everything except process it. We'll see. All right, so now let's go ahead and write these things. So we need Shunting Yard CPP. So this is going to include Shunting Yard HPP. And put these couple of guys in here. All right, and display, we'll actually just call our linked lists display. So that'll be just this dot what I call it, input queue display. All right, so before we go any farther, let's just make sure I didn't break anything. So that's an HPP. Oh, no, that has the semicolon after it. Yard, private colon, string expression. This is an HPP. Oh, I need to have a semicolon here. Did I write something to return an int? Shunting Yard, defined here. I feel like this has to be spelling. Shunting Yard, HPP. It felt like since I wasn't getting nice highlighting, I'd done something funky.
In your CPP for Shunting Yard, doesn't void have to go before?
Oh, this dude. It does. Thank you. I feel like that all the error messages weren't just from that though. This seems to be complaining about, is that the string? Forbids declaration of linked lists of strings with no type. Oh, it's not called linked list of strings, it's called Shunting Yard. I already had it in my mind. I was turning it into a linked list of strings rather than the constructor being named the same thing as the class name. All right, he's happier now. All right, so sorry about that. That's rookie mistake. All right. So now let's go ahead and build this guy out. So coming into, so effectively what we're doing here, we just built this into an object since that's what we're going to express. Ultimately do moving forward is we're taking in this string expression here is going to look something like that, dude. And what we're going to do is produce this out of it. All right. So we want to walk through this string, building up each of our tokens. Now you could make some assumptions if you want. You could decide that you don't care if there's spaces or no spaces. You can say, I'm going to make this so that there's I only allow no spaces. So everything has to be put together. You know, you can kind of decide. We'll go ahead and make this so that it doesn't care about spaces, let's say. It'll be an interesting little extra exercise for that. All right, so what we want to do is we want to walk through this string from beginning to end, collecting our string until we hit an operator. So one of our things that counts as a legal operator, okay? And we want to ignore spaces. So if we, so we're going to go ahead and we're going to say, is this an operator? No, collect it. Is this an operator? No, collect it. Is this an operator? No, collect it. Is this an operator? Yes. So what I want to do, I want to add the dude I have just been collecting to my linked list. And then I want to empty that out, grab the operator, add that to my linked list, then collect again. Is this an operator? No. Is this an operator? No. Is this an operator? Yes. Add to my linked list, empty out, collect my operator, add it to the list. Is this an operator? No. Is this an operator? No. Is this an operator? Yes. Add it to my linked list, empty out, collect my operator. Is this an operator? No. Now I hit the end of the string. So we should have one last number stored in that collection string that we want to tack on to our linked list. So this is going to be our mechanism for our algorithm for extracting these individual tokens from this string into a list like that. And we'll just add stuff to the end. We'll always be adding to the end of the list since we're doing that, using this guy as a queue. All right, so here in the constructor, we're going to have our our cur token. We'll start this guy off as the empty string. All right, and we want to walk through every character in expression. So for int I is equal to 0, I is less than expression dot length I plus plus. We need to make sure that we go ahead and let's set our couple of fields. We're going to go ahead and just remember our expression in string form in case we want it. And then we do need to initialize our linked list. So we have a place to put those individual tokens. So this expression is equal to the expression that was passed in, and this input Q is equal to a new linked list of strings. All right, so now we're going to be building up our current token inside of current token. Now we need to be able to identify operators. Okay, so it might be helpful for us to maybe create a private function that I can pass a character to, and he'll tell me whether or not something is an operator or not. Put that in here. I'm going to make it private because we only need this internally inside of our Shunting Yard class. So this guy will return a Boolean. Is it all caps or lowercase? I think it's all caps. Well, it'll scream at us. Boolean is operator. We'll pass it a single character. We'll go ahead and implement this guy. All right, so here's his operator. It'll take in a character C, and we want this guy to return true if C holds one of our operators and false otherwise. So return C is equivalent to a plus sign, or C is equivalent to a minus sign, or C is equivalent to a multiplication sign, or C is equivalent to a divide. For Shunting Yard, do I want to leave it at that? See, Shunting Yard also supports, well, we want to have parentheses in there, or that. Or C is equal to closing parenthesis. We can do mod and we can do power because those are represented in this. Things to an exponent operate a little bit funky. So here's all of our operators, and then an exponent has like an extra precedent. So we'll throw it in there. Actually, you know what? I'll put it in there. Or C is equivalent to that guy. So we'll return true if any of those things is true. If the character I pass that is either a plus sign, a minus sign, a multiplication, a divide, an open parenthesis, a closing parenthesis, or the caret, if it's any one of those, it's an operator, which means I'm done collecting my previous token, right? And I'm ready to add my previous token as the next thing, and then add my operator as the next thing. All right, so up here, we're going to ask if is operator expression. I like using the local variable expression. The one, I guess it doesn't matter. Understand that when I say expression like this, that is a different variable than that version of expression, even though right now they both hold the same value. because I set them to be the same value here. Just saying expression is the most local definition of expression, which is this guy right here. This dot expression, or this arrow expression, this is the variable owned by the class. This is the field owned by the class. So as far as this is concerned right here, they're synonyms. So I'm going to pass in to isOperator the current character. If that guy is an operator, then I want to add the current string to my linked list. So the current thing I had been collecting. So this input queue add end per token. Then I'll say this input queue add end the string version of the current character. And then cur token will empty out. So if I've hit an operator, what am I going to do? I'm going to take my current token I've been building up, I'll add it to the end of the list. Then I'll make a string out of the operator I'm looking at. I'll add him to the end of the list. And then I need to make sure I clear out my current token in preparation to start building the next one. All right. If I'm not looking at an operator, I might be looking at a thing I want to collect, or I'm looking at a space. If I'm looking at a space, I want to go ahead and just skip to the next version of this function. So I can say else if, or this loop rather, this dude is equivalent to a space, continue. Just skip the rest of this time through the loop and move on to the next time through the loop. And you could have accomplished this a couple different ways. You could have put that maybe in the, I guess you would have had to say, maybe is something a number? You could have written, if is it a number? There's probably a built-in function, or we could have written something similar to isOperator. But right now we're assuming that our string is filled up with numbers, operators, and spaces. So we're just explicitly asking the question here. If it's a space, do nothing, move on to the next iteration. That's what the continue. So continue fits in that same category as break and return. Return makes a method immediately end. Continue moves on to the next iteration of the loop immediately without doing any more logic in here. And break breaks us out of the current loop we're in. All right. Else, I must be looking at a number that's in the process of building up my token. So I'll say cur token is equal to cur token concatenated with the current character. All right, and I'll do that until I'm at the end of my string, my expression. And now I know I have one last token stuck inside of cur token. Because I hit the end, but I never actually hit another operator to trigger me to throw it into my linked list. So I have one last guy stuck in there, so I'll go ahead and tack him onto the end of the linked list, and then this constructor's job is done. He has taken our string version of our expression and turned it into its linked list form. So if everything went to plan, I should be able to come back in here. I should be able to bring that guy in. That will be the string. So I'll go ahead and pass my shunting yard My expression is 123 plus 14 minus 28 times 2. And then I'll tell that guy to display himself. Lowercase, right? All right, we are missing, well, we got some interesting stuff going on there. Let's go here. Cur token is the empty string. Cur token is equal to cur token followed by a. This is how I get a single character out of here, right? Cur token's a string. I get my string stuff from HPP. String standard. Here's my linked list. We've tested the linked list before. I'm going to go ahead and give myself just make sure we're getting the tokens the way I or not. They are empty strings. Make sure the character I'm passing in here. Yep, so I'm passing in all the correct characters to here. Well, that should be okay. So is that an operator? No. Is that an operator? No. Is that an operator? No. Is this an operator? Oh, comes back as 1 for everything. When I printed out that, it's then saying it's not one of these. Actually, it's saying it is one of those. It thinks everything belongs here. Or C is equal to minus, or C is equal to times, or C is equal to slash, or C is equal to open parenthesis, or close parenthesis, or caret. If it's any one of those, return true. Just make sure I'm getting the value I think I'm getting for true here. Yeah, true is a 1. 0 is a false. Why is this always true? That's my one being printed out right here. And then it's saying that one is one of these guys. Oh, right here. Or that. All right, so now we're getting the right question there. Back to return that. All right, so it's when I'm grabbing my operators that the current problem is. So I'm getting the right stuff here now. So that guy's good. We should see. Let's just see if that operator is showing up. This concatenation might not be working. Yeah. There's the three operators there, but before I wasn't getting those, was I? No. So this guy concatenating a character onto the empty string does not work. Why not? Oh, it's a good reason, actually. Problem is, because as we talked about before, C++ has multiple kinds of strings. When I'm doing this, how does C++ know that that dude is our new special kind of more modern string, as opposed to the old school char pointer? I might be able to say, treat this dude like a string, and he might work out then. I'm guessing that will work. Yeah, so I could typecast that. So if I typecast that, now I'm specifically saying, hey, this dude right here is specifically one of these dudes. All right, so there's my stuff split up. So kind of an interesting thing to look back at, old style strings versus new style strings, because we do need to be careful about just haphazardly throwing double quote out there and saying, oh, in Java, this is perfectly fine. String's a string. Well, on C++, a string isn't necessarily a string. It's really asking, well, what kind of string are you talking about? Talking about the string from 1968. Then we had C strings in the middle, which we haven't even looked at. That was from the standard template library. Now we're looking at a more modern version of string. So which kind of string are you actually talking about here? All right, so this guy will get us our linked list of stuff. All right, questions about where we're at right there? All right, so finally, well, now let's go and look at Shunting Yard. All right, so let's just walk through the algorithm by example here. So first of all, if I scroll down here real quick, notice they have a little chart that talks about the operator precedent. Okay, so this is going to be very important for this algorithm. Basically, really, these numbers don't actually matter. It doesn't matter what the number is. What matters is their size relative to the other guys. Multiplication and division has a stronger precedence than addition and subtraction. Something to the power has a stronger precedence than multiplication and division, which has a stronger precedence than addition and subtraction. We need to be able to ask that question. Is the operator I currently have, is he more important than the operator that's currently at the top of my operator stack? Because that will make a difference. Okay, that's part of what Shunting Yard has us ask. Because remember, the ultimate goal here is to be able to go through and process a string that looks like that and actually do the math correctly following the orders of operation. That's effectively what we're trying to accomplish with Shunting Yard. All right, so all this rigmarole just to say, hey, as a human being, I can go through this, do this pretty easily, except maybe it might not necessarily be general knowledge that something to the power actually has the highest precedent. That kind of gets floated out there into some rules that were in some books some years ago that you never looked at or something like that. But in general, most of us know that multiplication is a bigger deal than addition in terms of what should happen first. And then we also know that, hey, this parentheses stuff kind of just that butts in line in front of everybody else. Okay, so Shunting Yard takes these things into consideration. All right, so given that, let's walk through this guy here. All right, so we're not, I mean, so in this example, it doesn't matter what these numbers are, A, B, C, and D, they're numbers. What we're really focusing on here is the operators, right? All right, so first thing we do, so we're processing this input queue, that thing we just built. All right, so we read off the front of the input queue, the first dude in line, and what we do is we find, in this case, an A, which is a number. Okay, this A, B, C, D, these are numbers. So I'm going to find a dude that's a number. I'm going to say, ah, you're a number. What do I do with numbers? I immediately put you in the output queue. That's where numbers go. We don't ask any questions. You're a number, put you in the output queue. So you'll have to figure out a way to determine if something is a number. Okay, maybe write a function that you could pass a string to and it returns true. If that string represents a number, false otherwise. Think about how you might accomplish that. All right, using the tools you have available to you now. Don't, I mean, there probably is a function that's built into the string class, but I'd encourage you to write some sort of MacGyver type function that says, how do I detect numbers in the form of a string when I see one? All right. Oh, just happened there. Oh, I must have clicked the picture. All right, so if I see a number, I just put it in the output queue. Next thing, I find an operator, plus sign. I look at the top of the operator stack. I see nothing there. So I go ahead and just push it onto the stack. Next, I hit a number. What do I do with numbers? I just put them on the end of the output queue. Next, I hit a multiplication. What do I do with the multiplication? I look at the top of the operator stack, and as long as the operator that I currently have, which in this case is multiplication, is at least as powerful as the thing that's at the top of the stack, at least as powerful, not more powerful, because remember, multiplication division, they happen in left to right order, right? They're kind of tied, and then we just deal with them in the order which we ran into them. So if it's at least as powerful as the dude at the top of the stack, which was a plus, multiplication has a higher precedent than addition, so it is more powerful. So I'm allowed to go ahead and push that multiplication on top of the plus sign. Okay. Next, we read in the C, it's a number, we just put it on the output queue. Then we read in a minus. Is a minus at least as powerful as a multiplication? It's not. So we have a problem. What do? We pop the multiplication off our operator stack, putting it onto our output queue. Then we, in order to get left to right, it actually is going to be, has to be less than, not at least as powerful. No, it has to be greater than, not at least as powerful. So let me go back and ask the questions again. Is multiplication more powerful than addition? Yes, it is. Is subtraction more powerful than multiplication? It's not. What do? We pop the multiplication off the operator stack and put it at the end of our output queue. Then we ask the question again. Is subtraction more powerful than addition? It's not. So we again pop the addition operator off of the operator stack and put it at the end of our output queue. So before we were allowed to put subtraction onto our operator stack, we had to pop multiplication as well as the addition off of there to allow us to put the subtraction onto the stack. Because at that point, the stack was empty, so it was a free-for-all. Then we get to our last thing here, which is number. What do we do with numbers? Immediately put them on the output queue. Now we're done with our input queue. What do we do when we're done with our input queue? We clear the operator stack. So we just keep popping from the operator stack until it's empty, leaving us with an output queue that has the things in it in the order we should deal with them. All right. So A, B, C times plus D minus. And I'll show you as an example there. But before we go on, are there questions about the algorithm up to that point? How our output queue is finally built? We're not asking the question yet how it's processed. We're asking, how do you build that output queue? Because that's what we're going to do for Monday. So we're going to take our current input queue, which we built, and we're going to ultimately build this output queue by way of the Shunting Yard algorithm, which manipulates this operator stack. Go ahead.
So, are we just gonna assume for like the homework that the parentheses and exponents?
Well, exponents will follow the same rules as this. Parentheses, I'll show you down here. We do want to handle those. Yeah, so here's an example that deals with the parentheses. So if we have 3 plus 4 times 2 divided by 1 minus 5, yada, yada, yada. So this shows you what we do. We hit a number. What do? Add it to the output. We hit a plus sign. What do? Nothing's on the token, the operator stack, so we push it onto the stack. Hit a 4, add it to the output. Hit a multiplication. What do? Is it stronger than a plus? It is, so we push it onto the top of the output stack. We hit a 2, add it to the end of the output queue. We hit a divide. What do? We ask, is it stronger than a multiplication? It's not, so we pop the multiplication onto our output queue. Then we're able to push the division onto that because it is stronger than the plus sign. Okay, so now it looks like this. Then we hit the parenthesis. What do we do with the parenthesis? Parenthesis goes on to the output, goes on to the operator stack. Automatically, an opening parenthesis goes on to the operator stack. It's the closing parenthesis that says you need to do something now. We'll see it here in a second. So as soon as I hit that open parenthesis, we didn't have to ask any questions. This guy dictates, push it onto the operator stack. We hit a number. What do we do with numbers? Put it on the output. We hit a minus. What do we do with that? Now, a minus, we ask, is this at least as strong as the current thing at the top? We're treating the current thing at the top as super weak. Basically, we can say that an opening parenthesis is the least powerful, right? It always loses, so it always is, well, least powerful is probably the wrong thing. It's a special case, being that it's the beginning of a parenthesis thing, and we'll see how the closing works. So if the top is currently a parenthesis, an opening parenthesis, we are allowed to put anything on top of it. So we put the minus sign on top of it. Hit a number. What do we do with numbers? We put it at the end of the output queue. Now, we hit that closing parenthesis. What do we do when we hit a closing parenthesis? We don't need to store that because ultimately our output queue is going to dictate the order of operation we should do our math. So when I hit that closing parenthesis, what am I ultimately going to do? I'm going to pop the opening parenthesis off, not store it anywhere, just get rid of it, because that's not part of my my order of operation, other than it dictated how I'm going to be building my output queue. Then I'll move the division. Hold on, let's see. Yeah, so I need to pop to the, when I hit that closing one, I need to pop until I hit the opening one and clear the opening one. So I pop the minus sign off, that goes to the end. The next thing I ran into was the opening one. I pop that off, but do nothing with it. So I've captured the operation that I wanted to make sure I did first. So when I see a closing one, I pop operators until I find the corresponding opening one and get them onto the output queue. So my op stack looks like this. My output queue currently looks like this. Notice I'm not storing any of the parentheses. I hit a exponent. What do I do with this? Well, it's the most powerful, so I know it's more powerful than the guy at the top. Probably going to ask if it's another exponent one, but at that point it doesn't matter. Exponent and exponent kind of doesn't matter which order, but we will pop if there's two of them. So we'll push this guy on. Then we hit a, where's my next guy? We hit this, it's more powerful than division, push it on. We hit a 2, what do we do with numbers? We put it at the end. We hit another exponent, what do we do? That's actually interesting. We pushed it on because an exponent is not more powerful. So why wouldn't, oh, that's the catch with these. It's a special case with exponents because they're actually evaluated left to right, or I'm sorry, right to left instead of left to right. So with our one special case in all of this is if I have an exponent, I'm asking the question is it at least as strong as the guy above it? If it is, then I can push it on. So that's why we didn't pop the exponent off before we push this on. It's because exponents follow this special rule of being evaluated from right to left. All right, so this example goes through that. So we'll push that on, we get our 3, add it to the output. Now we hit the end of our input queue. What do? We just clear our output queue. So pop the power, pop the division, pop the plus. So this will be our output queue. Make sense? All right, so your homework for Monday is to implement Shunting Yard up to the point that it produces the correct output queue. We're not doing the math yet, just produces the correct output queue. And this guy's pretty verbose here. So really your test bed could be this guy right here. If it works for that, I think it'll work for anything. Makes sense? Because that's handling parentheses as well as powers. All right, questions about that? I'll give you the current state of the code so you have that as a starting point. Questions, comments, concerns, bribes? Okay, I'll see everybody on Monday. So the next week we'll